Okay, today we're going to look at dividing rational functions, and it's very similar to multiplying. There's just a slight bit difference between multiplying and dividing. And this goes back to what you learned in elementary school. If you want to divide fractions, you've never divided fractions, you've always flipped and multiplied because there is no process for dividing. It's always turned everything to multiplication. Just like when you learned to do positive and negative numbers, you never subtracted them. You always changed it to plus and negative or add the opposite. So same kind of thing here in multiplying. We're going to do the opposite. So we're going to take this second fraction and flip it over so that we can multiply. And the first fraction stays the same. You always flip the second one because that's what changes it from multiplying to dividing, and you change the dividing symbol into multiplying when you flip and multiply. Now the next thing you do is, this is a monomial problem. Now I only have one of these in our notes for today. But you start off with the coefficients, and you put the coefficients over here together, what was on the numerator and denominator. Then you put your x's. So there's an x to the third and an x to the 8 on the top, and an x to the 7th and the 5th on the bottom. And I accidentally just wrote those two backwards, but it doesn't matter, because I said 5th at about the time I meant to write 7th. And then I have a y to the negative 4, which needs to come down and go with y to the 2. And here I have a y to the 4th that needs to come down with the y to the 2. So therefore, I end up with a lot of y's on the bottom. So in working with my variables, that makes 12 y's on the bottom. Let me try that again. 12 y's on the bottom. Now with my variables here, that's 11 x's. This is 12 x's. So if you subtract, there'll only be 1 x left on the bottom. Now if you start reducing these numbers over here, 12 is divisible by 6, goes 2 times. 6 goes into here 3 times. Then if you wanted to cancel the other ones, 16 is divisible by 8 2 times. 24 is divisible by 8 3 times. But then I noticed that my 3's are on top and bottom, so they can cancel out, and my 2's on top and bottom can cancel out. I have nothing left in that fraction, but I had to put something on top, so I put a 1. Now the rest of my examples are going to have some kind of factoring in them, but I look at this second one and I realize it doesn't factor at all because that's a monomial and a linear, so I can go ahead and write them down. And over here my 2x squared is a monomial, so I can go ahead and write it down. So first I have to come up with 1 times negative 5 is negative 5. But I needed to come out to be positive 4, so the negative needs to be on the 1 and the 5 needs to be positive for it to add up to 4, but multiply to be negative 5. So it's going to be x minus 1 and x plus 5. Now I can cancel. The x minus 1's cancel. 2 goes into 4 2 times. X cancels one of the x's, leaving me with a 2 and an x plus 5 on top over x is all that's left on bottom. And that 2 has to be in front of that parentheses because it's a monomial. And they always start with monomials if you have any. Now in this problem, the only thing I see that doesn't need factoring is x plus 2. So first we'll factor this one, and this looks like it's square rootable, so I'm going to try perfect, which says square root the first, which will be x, and square root the last, which will be 4, and take the sign from the middle, which is plus. But I don't know that that's what it is. I'm just trying this. So to make sure I know it, I'm supposed to go 4 times x and double it, and 4x doubled is 8x, and matches the middle, so it was perfect. Over here, I'm going to take the top one and I'm going to factor it on the bottom. So x times x makes x squared. 1 times 8 is 8. And the factors of that are 1 and 8 and 2 and 4. And they're all positive. So that would have to be 2 and 4. So I'm moving it to the bottom because I'm flipping and multiplying as I go. I'm supposed to flip this down here. Now this one's coming to the top. It's food line, or what we call difference of squares, where you fill in x times x makes a quantity squared, 2 times 2 makes 4, and a negative and a positive make the negative. So now I can cancel x minus plus 2 with x plus 2. One of the x plus 4's we'll cancel one of these on the top. And then I'll have x minus 2 over x plus 2 to go with the x plus 4 in the first one. At first I thought I might have done that wrong because I was thinking I knew what the answer was, but I guess I'm remembering a different problem. Because I did cancel out x plus 2's. And you know, just to reiterate, I didn't have to come all the way over here to mark out this x plus 2. I could have done the one that was over here. I just didn't think about that at the time. It doesn't matter which x plus 2, you just can't do them both. So in our next one, the top doesn't need factoring. Two numbers that multiply to be negative 14, because 1 times negative 14 is negative 14. 1 and 14, 2 and 7. But it's got to add up to negative 5, so the second one needs to be negative for it to multiply to be a negative, but add up to negative 5. So that's going to be x plus 2 and x minus 7. Then we're going to flip, and the bottom one doesn't need factoring, so we're going to make it come straight to the top. But the top one does need factoring, so as I go, I'm going to factor that one into x minus 3 and x plus 2, because 2 times 3 is going to be negative 6 if one of them is negative, but it adds up to negative 1 in the middle. Now in this problem, we have x minus 3's that will cancel out, and we have x minus 7's that will cancel out. Oh, this is the answer I was thinking of earlier. But I have 2 of the same thing left on the bottom, so I write x plus 2 quantity squared. Since I had nothing left on the top, notice I wrote a 1, because you have to have a top to a fraction if for something to be left on the bottom. Number 5. Well, this one over here needs a 1 under it, and if I flip that, that'll be 1 over x plus 6, which doesn't really need factoring or anything, just needs flipping because of the division. Here I need to take out the GCF of 3x and get x plus 1. On the top I have 24, so 1 times 24 is 24, so I'm listing the factors of 24 to see which one adds up to 10, which was 6 and 4. So x plus 4 and x plus 6. Now as we said before, any numerator parentheses can cancel a denominator parentheses. But that's all I have that cancels in this problem. So I put back everything else that's left for my final answer. Okay, in our last question we have a combination of 2 different problems going on. First, in our bracket we have division. So if I take out an x on the first one, I'll have x plus 11. And if I say divided by x minus 2, because it doesn't need factoring. And I'm going to flip this one and put a 1 under here, makes me the 1 go to the top. And if I take out a 3x, I get x plus 2. Now I could put these two together right now, but over here is another multiplying one, and you can multiply 3 fractions at once. So I'm going to just factor the top into food line of x plus 2, x minus 2, because the bottom doesn't factor. And now I can see quite a few things that will cancel. First I have an x plus 11 that cancels an x plus 11. Then I have an x minus 2 that cancels an x minus 2. Then I have an x plus 2 that cancels an x plus 2. Then I have an x that cancels the x, because that x is not on that 3. That's what people think. They think those 3 x's have to stay together. No, that's 3 times x. So I can take the x and cancel it, because the 3's not really on it. And that makes the answer to this question 1/3. So this is the same thing that we looked at yesterday, except for that one step. You can flip and multiply and get your answer. So now you can go back to the lesson on 0.2 and complete the entire worksheet that we started yesterday on multiplying and dividing. We did the multiplying problems yesterday from 1 to 10, so you can complete the rest of that assignment.